This is the second in a four-part series on how to build your own solar generator or portable camping solar power supply. In this case, we're going to talk about parts and battery matching. Okay, these are the tricky bits. The systems I have seen failed mostly because they had a poorly matched solar panels. The solar panels were too small. The system fades away because it just cannot provide enough power. The solar panels cannot provide enough power to keep the batteries charged. Or poorly matched batteries. If they're too small for the system, it's going to run out of power during the night when there's a no sun situation and so forth. Or if the batteries are too big for the panels, and a lot of commercially available solar generators are like this, they never get fully charged. So the batteries are never fully charged and it shortens the battery life. So poor matching is one of the most common reasons that systems do not work. So we're going to match the four parts. The solar panel, the output, that's the stuff you want to drive, that you want to power, your radio, your lights, your tablet, PC, phone, whatever you're going to do. Storage, and we're talking about batteries, probably gel cell or lithium these days. Controller. And so let's look at these three system states. The three system states are charging, discharging, and maintaining of the battery. Okay, so if the battery is in the charging state, this is what's going on. The solar panels, the input is high. The input is higher than the output required. And the excess electricity is going into the battery. The battery is charging. The next state is discharging. So the solar panel output is smaller than our load. And that means that the load is going to pull from the battery, and the battery is therefore discharging. So more electricity is being used than is being supplied by the solar panels. The third state is maintaining, and this is where the solar panel production is equal to the load needed. So whatever you're using, your radios or whatever, are using exactly as much as the solar panel is producing, and the battery is staying at a neutral position. It's not increasing or decreasing in charge. These states, the charging, discharging, and maintaining, change because solar input. You can have clouds, time of day, leaves fall on your panel, stuff like that. Output demand. So you use more or less power. You use more lights than you thought you would, or fewer radio or hours or what have you. And the battery condition. Older batteries hold less charge, fact of life. Matching these parts is a bit of guessing, but you can get it close enough to make it work very well. So here's how I did it. I guesstimated the needed power I was going to use, and in my example, mine is primarily for camping and for when I have no power around the house. I want to run one LED light, 9 watts, that's pretty extreme, and for 5 hours. I want to listen to the radio, which is 12 watts, or charge my handy-talkie for 2 hours every day. I want to charge my phone, which is also 12 watts, for 2 hours every day. And I want to charge my tablet PC, which takes 12 watts, and for 4 hours. It takes 4 hours to fully charge it. So let's start with the light, and that's this one up here, the LED light. It's 9 watts divided by 12 volts. It gives me 0.75 amps. That's how many amps I'm going to need. I take the 0.75 amps times the number of hours I plan on using it, 5 hours, you can see there, 5 hours, which equals 3.75 amp hours. So these amps and these amp hours are two important numbers. And we're going to need that for everything that we're going to use, that we plan to use. Okay, so our camping example. So the first thing, we've already calculated our light. It's 3.75 amp hours. The next thing is our radio. It's 12 watts. 12 divided by 12 is 1, so I need 1 amp. 1 amp times 2 hours, because I said I want to use it 2 hours a day. 2 amp hours. The phone, 12 watts, also 12 volts, 1 amp, and so I get the same result, 2 amp hours. Tablet, 12 watts, 12 volts, 1 amp, but I'm going to use it 4 hours, so I get 4 amp hours. So these numbers are going to be important. It's 3.75, 2, 2, and 4. Now we're going to add them all up, 3.75, 2, 2, and 4, and we get 11.75. Let's round that up to 12 to make the math easier. So this is the minimum battery size we need. For a minimum battery, we need a 12 amp hour battery. So 12 amp hours is the minimum we can get by with for a battery, right? Well, maybe not. What if I charge my phone and tablet, that's 6 amp hours out of my necessary load, what if I charge those during the day when the sun is shining? Then I would only need 12, the 12 total minus the 6 here. I would only need 6 amp hours of battery, right? And that would mean a battery half the size or half the weight. Well, yes and no. If the solar panels have extra power to charge the batteries during the day, and the devices, so my storage battery and these two devices at the same time, then yes, I can save myself some battery weight. So I would choose, and I did choose, both the 12 amp hour battery and bigger panels, and use this technique to give me surplus power to handle, for example, when it's cloudy or something, when I want to use more power. So this little trick of having a little bit bigger solar panel than I have batteries and charging some of my other stuff during the day can save me some battery weight. Okay, so guesstimate the needed output. One last thing. To finish this design, we're going to need to know how many things we're going to use at the same time. So we calculated each one of their uses in total amp hours, but now we need to know the total number of amps they're going to pull. And we're going to use this when we calculate our wire size, our plugs, fuses, stuff like that. And let's say we're going to use 4 amps total, so we're going to probably use 2 items at the same time, maybe the lights and the radio or something like that. So the maximum we're ever going to use is 4 amps. So all the wiring, fuses, stuff like that inside the box has to be able to handle a minimum of 4 amps. Let me throw in a side note here. A couple of my friends wanted to use inverters, and an inverter is where you take your 12 volt output and you convert it either to 110 or 220 volts. And I don't recommend that because, first of all, the inverters are very inefficient. They will cut your the battery use time in half. And also, when you're camping in wet situations, 110 or 220 volts is deadly. It'll kill you. It's just like what's coming out of the wall. So I'm not going to recommend inverters. Okay, step 1, when I design a system, let's go through this, a summary. Guesstimate the output of the power requirements. Determine the number of devices you're going to need to use at the maximum amperage of each. And we've already done that. For the next 2 videos, we're going to say we need a 12 amp hour battery, 4 total amps maximum. We're actually going to do more. We're going to build the system to be a little more robust than this. And we're going to say we're going to use 2 items at the same time.